Welcome to solverfy.
When you're given one quantity of a chemical substance, you can change it to another by using the different relationships, including molar mass and Avogadro's number. It's good to write out a plan to go through the conversions and then to do the math using dimensional analysis. So if, for example, you know that you have a certain mass of a substance, say 33.1 grams of SrF2, and you know that you want to find out how many ions are in that quantity. We always need to start by changing our mass to moles. So we know that we start off with 33.1 grams of strontium fluoride, and we change it to moles. And we do this by using the molar mass. And remember, the molar mass is found by using the atomic number of the different elements found on the periodic table. Once we have moles, we can find out how many formula units. And we do this using Avogadro's number. And finally, once we have formula units, we can tell how many ions based on the chemical formula. So if we start off with our initial mass, we should find the molar mass. So to find the molar mass, we use our periodic table and we look at the atomic weights of strontium and fluorine. Strontium is 87.62 grams per mole, and fluorine is 18.998. Because there are two fluorines in the formula, we multiply by 2. So the molar mass of strontium fluorine is 125.62 grams for every 1 mole. So now we can change our grams to moles. We know that 1 mole is equivalent to 125.62 grams. Once we have moles, we change to formula units using Avogadro's number, 6.02 times 10 to the 23rd. For every 1 mole. And finally, for every 1 formula unit, we need to know the number of ions. And strontium fluoride is made up of strontium, 2+, and 2 fluorine ions. So there are a total of 3 ions. So we multiply 33.1 times 6.02 times 10 to the 23rd times 3, and then divide by the molar mass. Which equals 4.76 times 10 to the 23rd ions. Instead of given mass, you may be given number of moles to start with. 3.58 moles of CuCl2.2H2O. This is an example of a compound called a hydrate, which means that it's made up of copper and 2 chlorine ions and additionally 2 water molecules. So when we find the molar mass, we need to take into account all of those different components. And we want to change it from moles to kilograms. So we know that we start with moles, and we want to go to grams first, using again the molar mass. And then from grams to kilograms. Simply using the idea that there are 1,000 grams for every 1 kilogram. And so we just need to figure out our molar mass using the periodic table again. So it will be the molar mass of copper, which is 63.55 grams, plus 2 times the molar mass of chlorine, which is 35.45, plus 2 times 2, or 4, times the mass of hydrogen, plus 2 oxygens, which equals 170.48 grams. So we start off with our initial moles. To change to grams, we know that 1 mole is 170.48 grams. And once we have grams, we can change to kilograms, because 1 kilogram is 1,000 grams. So multiplying 3.58 times 170.48 divided by 1,000 is equal to 0.610 kilograms. Finally, we can start off with a formula unit, or a small particle, such as 2.88 times 10 to the 22 and change that to mass, or milligrams in this case. So we'll start off with a small particle, the formula unit, change it to moles, and the relationship between formula unit and moles is Avogadro's number. Once we have moles, we can change to mass using molar mass. And then finally, we can change to milligrams using the relationship between milligrams and grams. There are 1,000 milligrams in every 1 gram. So the only other information we need to know is what the molar mass is of the compound. And our formula for our compound, this is bismuth nitrate, NO3 3.5H2O. So it's another hydrate, which means we have to include the mass of the water. And so 1 mole will have the mass of bismuth from the periodic table, which is 208.980, plus 3 nitrogens, 3 times 14.007, plus 3 times 3, or 9 oxygens, 99, plus 5 times 2, or 10 hydrogens, plus 5 oxygens. Or this compound has a molar mass of 485.067 0.067 grams. So we start off with our initial quantity given, 2.88 times 10 to the 22nd formula units. Changing it to moles, 1 mole is equal to 6.02 times 10 to the 23rd units. And then we can change it to grams, 485.067 grams for every mole. And then finally we can change to milligrams, 1,000 milligrams for 1 gram. So multiplying 2.88 times 10 to the 22nd times 485.067 times 1,000 divided by 6.02 times 10 to the 23rd leaves us at 1.5. Leaves us at 2.32 times 10 to the 22nd. All right, 10 to the 5th. Milligrams.